Well, greetings out there in YouTube land, and welcome to today's blockbuster video featuring the contents of this very large and cumbersome, not to mention heavy, box. It actually required the use of the hand cart to get it here into the workshop. So let's, without further ado, open this jewel up and see what surprises await us within. Well, it looks like we're confronted with the old box in a box ploy here. The inner box has been insulated from harm all the way around by these air bags, except on one end, and let's hope that that one didn't suffer any damage as a result of no real padding. Okay, without further ado, let's move those bladders away and let's take a look at what's in that inner box. Well, after adjusting my truss, I've managed to hoist the massive inner box up here onto the workshop tabletop, and I looked in the bottom, and lo and behold, 2 packs of treats for Casey, Jack, and Ollie. We really appreciate it. And also a little hint here as to what we can expect in the large inner box. And we see here a Bolgan ended power cable. So all you Marshall fans better get ready, because it looks like we're going to have something special to check out and repair. Well, after carefully removing about 3 square parsecs of bubble wrap and plastic wrap with bandage scissors, lo and behold, this is what lurked within the box. And for all you Marshall fans out there, I think this is going to be a moment to remember, because it is a JTM-45 MkII. And from what I can gather from this type of script on the front, the gold plexiglass front control panel, and all this is probably from late 1965, maybe early 1966. Now, JTM-45 Marshalls are of great both financial and historical value in that it was the very first amp that Jim Marshall ever created. Now, he started out with the regular JTM-45s like in his kitchen, on his kitchen table, building them by hand. But once he developed a market for these jewels, he had to get the equipment and space and all to move into some sort of mass production. And this, as a Mark II, would have been one of the early amps that were produced with a little bit better facilities and equipment. And also, it's my understanding that this particular amp was the very first to have the circuit which is designated as a model 1987 circuit. Okay, that number does not refer to any date or time of manufacture. It's just an arbitrary number. The 1987 is considered the lead amp for regular guitar use, and there were also amps made at the same time for bass and PA use that had different circuits. There are ways to tell the exact vintage of these based on the type of script that you'll see up here, and this script has been changed, but I think it's pretty much the way that the script should have been on this particular model. We're going to go over every square inch of it inside and out, so let's take a look here at the front with all the gold piping in place. There's a little disruption in the gold plexiglass. Off, standby, and indicator. Now look at all the tone controls. Presence, bass, middle, treble, high treble. And what's kind of strange is we have loudness 1 and loudness 2, which are going to control the volume then of this pair of inputs and this pair of inputs. Okay. Now, why I say unusual is that this knob seems to have 2 purposes: high treble and loudness for the first channel. But in reality, if you look here at channel 1 and channel 2, this is the channel that favors the treble frequencies, and this favors the normal frequencies. Okay, so it's as if the tone controls are over here on the left, and these are simply the 2 volume controls for the two very different channels. Now I think this harkens back to the fact that, as we all know, the Marshall circuit was originally based on the Fender 5F6A Bassman circuit. And in that circuit we have a bright channel and a normal channel. And in this case, the bright channel is called high treble, and we have our normal channel. Now, I think originally the bright was probably for regular guitar use, and the normal was for bass guitar use. So now let's take a look at a couple schematics to see if we can understand how the difference in tone was achieved between the two input channels. First, in the Bassman, you'll see that the bright channel comes in here to the first triode of the 12AY7, and then it proceeds to the volume control. Well, a 0.0001 microfarad cap provides a bypass for the high frequencies to get around that volume control, and that produces the brighter tone in this channel. Now on the JTM-45, let's look first at the normal channel. No matter which jack you plug into, you're going to be feeding the grid of the 12AX7 first triode. The output from there will come around here to a 1 meg volume control pot, which sends more or less of the signal to ground, and then what remains will be sent here around the loop and into the first triode of the second amplification stage. But when you plug into channel 1, or the high treble channel, you feed the second triode grid here of the 12AX7, and the plate output comes around here to a 1 meg volume control, and so far it's the same, but there are two bypass caps. This one here, which is 100 picofarads, will bypass the volume control, and then this one here, which is 500 picofarads, will bypass this resistor. So as you can see, the high frequencies are allowed to bypass both the volume pot and the resistor and proceed on to the same triode of the V2 or 12AX7 second stage of amplification. Now originally, possibly, channel 1 was for guitars and channel 2 was for bass guitars. You could look at it that way, but I think a more practical application of this difference is channel 1 for humbuckers, channel 2 for single coils. Okay, this tendency to favor the treble frequencies then will kind of clear up any muddiness that might exist in your humbucker pickups. Or as many people do, simply jumper channel 1 and 2 on your Marshall amp and get the best of both worlds. Now while we're in this area, let's talk about a second feature of Marshall amps, and that is, I think most will agree, they're about the loudest amps on God's earth for their wattage. And how does that happen when they're based on a 5F6A Bassman? Why are they so much louder? Well, let's talk about a couple good reasons for that. The first preamp tube in the Bassman is a 12AY7. It has an amplification factor of about 40. The first preamp tube in the Marshall JTM-45 is a 12AX7 with an amplification factor of 100. So right off the bat, in the first stage of amplification, you have a tube in the Marshall amp that has about 2.5 times the amplification factor of that in the Bassman amp. Also recall that these early Bassman amps used 5881 output tubes, which are sort of like a 6L6 GB, not a particularly high output tube, whereas the Marshall used either 6L6 GCs or KT66s, as are used in the amp that we've received, both of which have a much higher output wattage than 5881s. So even after Fender changed over to 606 GCs in the basement, they still had the relatively low amplification factor first preamp tube compared to the 12AX7 in the Marshall JTM-45. Okay, so I think these feet have been added to it, but the cabinet, the Tolex, the handle, absolutely extraordinary, I think, for an amp this old. It's just in beautiful shape. Let's turn it around and take a look at the back. Before we turn it around, I thought we might have just a quick little tidbit here about where the JTM came from on these very first Marshall amps. It's Jim and Terry Marshall. It's their initials. And the number 45 refers to the rather conservative estimate of the output power of this amp in RMS watts. In a business where the tendency is to way overrate your amps, just like the horsepower in American muscle cars, Marshall actually was rather conservative here, and I have no doubt that if you hooked one of these up to the gear necessary to measure output wattage, that almost all of these could make at least 45 watts of RMS power. As you can see, one of the original knobs has lost its little kind of gold anodized hubcap out here on the front. If any of you out there in YouTube land happen to have one of these little gold discs and would like to sell it, please let me know. And we can see that the rear is every bit as nice or nicer than the front. Okay, the Tolex is perfect. The gold screen to allow ventilation is in perfect shape. See the label, and it's kind of a shame they don't have an address, because in late '65, I believe, Marshall moved to Hayes in Middlesex, England, and that would give us a clue. If that address were on here, we'd know that it was late '65, early '66, but I really think there's no doubt that that's exactly what it is. We have here on the control panel, and this is white. I don't know how it's going to look in the video, but it's simply white and appears to be like plexiglass or bakelite material. It's not shiny, it's kind of dull. And we have here a 2-amp fuse, the Bolgan mains type of receptacle. We'll take a look at that. Remember, the power cord came with this. We've got, since these were made for use all over Europe and the United States, the transformer can accept 110, 115, 120, 220, 240 volts of AC supply, and depending on where you plug it in, you pull this jumper out and put it in to the right 2 holes, and you'll get the proper voltage for your circuit. The output transformer also came with a jumper so that you could use either 8 ohm, 16 ohm, or 100 volt, and I'm thinking that's one of those constant voltage types of speakers where you use the amp like for a PA system, something like that, heaven forbid. Okay, it was in the 8 ohm jumper position, and I'm going to put it back into that in just a second. There it is, and we have the 1/4 inch output jack for the speakers, just a single output jack. Also, everything is in a real shiny black finish. It's not corroded steel as we're kind of used to seeing. This is probably the serial number, and it's 1954. 4-digit serial number, and a low one at that. So with all that said, let's unscrew this rear panel and take a look at what's inside. Rear panel's been removed, and you can see that the extruded gold, probably aluminum ventilation screen is in just beautiful shape. We've got some cracks here from drying of the wood over time. Remember, it's really humid in England, and then when they send these to less humid areas, the wood will dry out and crack. Very typical. You can see that quite a bit of what looks like, I don't know, what contact cement or weather stripping adhesive has been slathered on here to hold this white panel on the rear of the chassis. The chassis itself has no affinity to our magnet, so it's obviously aluminum. And you can see where all the tubes have been removed and packed back here. So let's get them out safely, and then we'll proceed with our inspection of the amp chassis. Right, all the packing and tubes and all have been removed, and I can see one of the reasons this is such a heavy amplifier head, and that is, look at the size of the transformers in this jewel. Output transformer, power transformer, and filter choke. You see these really snazzy spring-loaded retainers, and we got a nice pair of vintage KT66 output tubes. We have 3 vintage 12AX7s, and we also got a pair of tube amp Dr. KT66s, which are closely matched in case we need to replace the vintage pair. We also got a really nice letter here from the owner of the amp. He introduces us to the amp. The only date codes he could find were on the mustard caps, which, thank heavens, must still be intact, which point to 1966. No codes on the pots, we'll see. 2 apparent problems. Volume control for channel 2 has an area about halfway up where the volume cuts in and out. Turned up past this point or down below seems fine. Let's hope there's not a damaged area on that carbon track inside the potentiometer. We'll disassemble it and inspect it to see. Okay, he tried to clean the pots, but there was no way to get into them. Second problem is red plating. A couple of years ago I noticed a degradation in sound, found a bad power tube. I replaced it, only to have the same thing occur again. Okay, what does this sound like to us? Those of you who have watched our videos know that coupling caps are a really common cause of kind of an acute onset of red plating. Okay, in other words, the amp's working fine, no problems, and then it starts to red plate. Something's going wrong inside, and almost always it's coupling caps. Why? Because we know that the coupling caps, being capacitors, will block the passage of direct current. So the B plus cannot get past them to the grids of the KT66s. Okay, if the B plus can get to the grids will become increasingly positively charged, which is like putting your foot on the accelerator, and the plate current will just run away within the tube, red plating and eventually destroying the tubes themselves. Okay, so I think that's what happened. He plugged in a new power tube and it failed almost immediately because it was subjected to the failure of the coupling cap. Now apparently both of the tubes red plate. Well, that makes sense. If one coupling cap goes bad, the other one's probably going to follow suit fairly soon. Okay, so we're going to look at that. He says the amp has been recapped. Well, if the original mustard caps are in it, apparently that was just the filter caps, and even that was years ago. Okay, other than that, it's original except for the logo. We already saw that, which was replaced when I got the amp 25 years ago, and the big cushy rubber feet that we spotted as being not original, but probably a whole lot better than original. Okay, the rest of this is just good luck, do your best, and keep me posted. So I think we know exactly what we have to focus on here, and I think to get started, the first move should be to remove the screws that are holding in the chassis and extract it from the cabinet. The extraction of the chassis is hampered just like it is in Fender chassis removal, where the nuts that hold the chassis to the retention screws are not captive, they just spin freely. So for each one of them you have to reach in, put your finger against that nut and keep it from spinning. Really kind of a shortcoming, but let's face it, it would have been real hard for them to weld those nuts to the aluminum chassis. The 4 screws are out, the chassis has been removed. We see that there is an aluminum plate at the bottom to shield the circuit, probably from RF interference. The interior of the cabinet shows that I don't see any patching or repair work, that it's, I guess, remained in sound condition all its life, which is really nice. Okay, let's set this cabinet aside and take a look at the chassis. And here's the chassis in all its glory, with the spot here for the GZ34, in this case 5AR4 rectifier tube. Okay, these very early ones were tube rectified, then they went to solid state and stayed that way. I see no markings on any of the three transformers. Those of you who are experts, I'm going to show you the transformers, and you see if they appear original to you. I bet they are, but it's really hard to tell. These very early amps, and in this case, this one particularly, has almost a homemade look to it. Okay, this is fairly thin aluminum, and it's kind of soft and lumpy, and I've never seen anything like this, but the ends are reinforced by what look like cast pieces of solid aluminum that are inserted on either end and then screwed in place to give structure and all to the kind of flimsy aluminum sheet chassis. As you can see, those pieces are on either end. Okay, they're very solid and probably confer a lot of strength to an otherwise rather flimsy chassis. Okay, let's flip this over and take a look at the circuit. Before I flip it over, let's take a close-up look here at this Erie, and I mean that as in Lake Erie, not weird Erie, electrolytic can cap. It has sort of a, what looks like anodizing, but it's not. It's a blue, kind of a plastic film around the outside, and it's says 32 microfarads at 450 volts. Okay, now I'm not sure if that's an original cap or original style cap. We'll have to check into that, but it is unusual, and I thought you might get a kick out of seeing it up close. Okay, now probably what you all been waiting for is the interior view. See the input jacks, all the potentiometers with the bus grounding wire, mustard tone cap. I see here that several of the capacitors have been replaced with what appear to be Asian caps. They might be okay, but maybe we can do a little better. Metal film resistor, great big Sprague atom. Okay, nice wiring on this. The turrets, nicely twisted filament wires, and they're color coded so you can preserve the polarity of your filaments. That may be original, and that definitely isn't, and neither is that. Kind of glaring to me. Okay, I believe that the electrolytic cap that we saw on the surface has been disconnected, that it's doing nothing, and that these are the replacements for it. I honestly think, from an aesthetic standpoint, this is a very valuable amp, and I really think I can aesthetically make the repairs a little easier on the eye. So, when dealing with an amp of this caliber, to me, cosmetics are as important as the actual technical aspects of the repairs. These look like pretty grubby pots here. Haven't seen pots this grubby since the last truck stop bathroom I visited. But these jewels are going to need some cleaning, especially that one that has a segment, apparently troublesome break in the carbon track. Okay, so we've seen the inside and the extremely inconvenient fuse here that needs to be replaced, I imagine, from time to time. And let's get started. One part of this amp is just a disappointment, and I think that is this wretched Bolgan 3-wire power cord, I'm going to construct a really nice looking original style power cord using this receptacle and a much more modern 3-wire cable. Okay, I've liberated that Bolgan receptacle from those really wretched wires, and I dug through my stash of old 1940s jukebox parts and found this type of receptacle here, and I've bent the little pins out and I've removed the bakelite disc and the wire. Now it looks to me like with these tabs bent in just the right amount, they can engage the threads of the Bolgan receptacle, and this can screw on and actually be, I think, very much like the original plug back that came with the original power cord. Okay, I prepared the new 3-wire cord with the short leads soldered and bent at 90 degrees so that they can go into the holes in those screw terminals. And one other thing that makes this cap ideal for this purpose is the inside is heavily insulated with cardboard, so there's no chance of a short against this that might shock you. Now, being very careful to observe the polarity of the receptacle, I've inserted the 3 power cord wires into the screw terminals and secured them. Now I've crimped those fingers over the threaded raised area of the Bolgan receptacle. And all we need now is a grommet back here to take up the space between the hole in the metal cover and the cord. The grommet fills in that empty space, and now we have a really nice, safe, and solid plug to connect our amp to the AC wall socket. Now, as a final touch, because I have a feeling the original was probably painted black, I sprayed it with some semi-gloss black. So now we've got a really nice looking plug for a really nice looking amp. Well, now one of my favorite segments of any video is opening up gifts from our very generous viewers. In this case, a gentleman named Mike Mendito received over a short period of time 4 separate packages here, so God only knows what's in them. Jack is very interested. Here comes Casey to do some serious sniffing, and from their reaction I can tell you this is good stuff. Okay, so let's start opening them up. Well, how about this for an absolutely fantastic haul? First off, a pair of channel lock crimping pliers. I've pretty well worn out my old crimping pliers, and these are way better, so that's going to really come in handy. 3 different gauges of crimp-on butt joint connectors for those of you whose butt joint isn't quite connected. Automatic wire stripper cutter, a color display, I believe, guitar tuner, a huge container of cat treats, which should last about a week and a half with these voracious beasts, and then the prize of all time, a vehicle super probe. Okay, that's all that it does right there. You can stop the video and read. I'll have to go back to school, I think, and learn how to operate this jewel. It looks like you use it for diagnosing and repairing electrical wiring in vehicles. So it's really going to come in handy because I do a lot of that. Okay, so the card that came with it said happy birthday from Mike Mendito and Sadia Rodriguez. So thanks so much to you two. Your generosity and kindness are unexcelled. Okay, we really appreciate it. Thanks so much. And Jack, of course, always enjoys that packing material. Thank you all. Looks like Jack is enjoying the shipping container. I know he'll be enjoying these too very soon. Since I find this kind of diagonally inserted modern capacitor to be very visually annoying here and just doesn't fit in to the circuit, I've been giving some thought to actually drilling a hole in the old worn out Erie capacitor and inserting a 33 microfarad capacitor. And to test my theory, I grabbed an old Mallory can cap and drilled an 11/16 hole down through the center of it, and you can actually press the capacitor down inside. I'll have to put an extension on the ground lead so that I have two leads coming out the top of the capacitor, actually the bottom of it, and then those can be wired into the circuit. The outside of the can cap would be visible to all looking into the back of the amp, so it would look original. And when you looked in at the circuit, instead of seeing that, you would just see the bottom of the can cap with two wires coming out and go into the circuit. And I think I'm going to give it a try. I think this the age and specialness of this particular amp require maybe some extra procedures here. Okay, so let's see how this works out. Before we start, two final little points here. As you can see, the new capacitor will press down inside the old one, and also you can see from this bubble here that there are internal problems in this capacitor which did necessitate its removal. Step one, I drilled out the rivets that are holding those two terminals. Now we're going to start with a small drill right at the center and then increase the diameter of the drill bit so that we gently increase the size of the hole that's going to be drilled down into this electrolytic capacitor. Well, the process was a little different with the Erie capacitor. It reminds me of when they would mummify people back in Egypt and they would extract the entire brain through the nose with different tools. Well, that's pretty much what I did. I now have a nice empty can. I'm going to insert a piece of foam that takes up the outside diameter here, and then press my new capacitor down in the center and then create a new cap for the capacitor. I'll show you in just a second or two how it looks when it's done. I had a change of plans with the stuffing procedure here on that 33 microfarad original Erie cap that sits right up here in full view on the chassis, and I was going to use a 33 microfarad at 450 Asian sourced capacitor, and I thought, well, you know, those KT66s operate at around 450 plate volts, and probably higher now, and that seemed a little shabby to me, so I stepped up to F&T, which I think is a better quality capacitor, 30 microfarads at 500 volts. Now the price I'm paying for this better cap is that it's much larger in diameter, so I had to use a rotary file in the drill press to open the hole up to allow this cap to fit in snugly. Okay, so I'm going to do that, and then we'll have the two leads coming out here through holes in this cap that I produced that I will then glue on to the capacitor and make it look even more original. Alright, I've soldered on an extension to the negative or grounded lead from the F&T electrolytic cap, and now it's time to press all that down into the Erie can and then attach the lid. The F&T cap is now nestled happily within the empty Erie can. I cut a few little blocks of foam to put around it to keep it pretty well centered and stable. Now it's time to glue the lid on. We know that the longer lead here is going to be the negative or grounded lead. There was no need to be concerned with it being a bare wire inside the can, since it's all going to be grounded anyway. Okay, the one we worry about is the positive lead, and it comes straight out the center. And here we have our reconditioned Erie electrolytic cap. So let's install it up here on the chassis and wire it into the circuit. Here you can see where that replacement cap has been just double stick taped in here, hanging over the hole where the original capacitor was. Let's get this out of the circuit, paying attention to the positive leads and where the negative was grounded. All right, I removed the replacement capacitor, and these two wires will be soldered together, and the positive lead will go to their junction. The negative is going to ground back here on this little grounding tab. Also, I'll be honest with you, this just sticks out like a sore thumb to me, this bright blue 0.047 microfarad cap. It's between pin 8 of the rectifier and ground. It's in the line, the B plus line, to the standby switch, and I think it's there to absorb the pop when you flip the switch. Instead of the B plus arcing across the contacts of the standby switch, it will go in here to the cap. Okay, so it will absorb that pop, hopefully. So let's replace that with an older, more appropriate looking 0.047 cap. Here's our Erie electrolytic cap back in its holder on the chassis surface. Now let's flip the chassis over and wire it into the circuit. So now the two replacement caps have themselves been replaced by a innocuous looking brown drop 0.047 microfarad cap and our restuffed Erie electrolytic, and you can see that the wires pass right along and connect to the positive terminal of the now F&T 30 microfarad cap, and that the negative end is grounded to the same tab as the 0.047. I'm in the process of installing the tubes so that I can turn the amp on through the current limiter and check up on the status of the circuit. The first one is a Mullard 12AX7, and then one I'm not familiar with, a Britmar. How about those potatoes? Made in England. Okay, the third one is a Sovtech. I might try to scare up a suitable third 12AX7 to keep up the British tradition, but for now it looks like at least two of our three preamp tubes are first quality. All right, the tubes are all in place. I have the Eurotubes bias probes positioned under the KT66s, which are based the same as a 6L6 or 6V6, so I can use them to bias these output tubes. I've got the signal generator putting in about 600 cycles per second, and I'm hooked up to the shop speaker system. So let's turn it on and see if, number one, the output tube's red plate, and number two, if there is a dead spot in the volume control. I believe it was for channel 1. Okay, so that'll be the two things we'll be looking for. All right, the tubes are heating up, and before I take it off a standby, let's take a quick look at KT66 tubes. A lot of you probably aren't familiar with them. They're like a sort of like a high voltage 6L6. The power out, if it's at about 500 plate volts, is around 50 watts in fixed bias. Okay, normally you expect a negative DC bias of about 67 volts being applied to the grids, but you can see that this being called a 45 watt amp is certainly within the realm of believability. Plate dissipation is about the same as a 6L6GC, in that 25 watts they say is a good working maximum, but that 30 watts is the absolute maximum. The pin out is the same as a 6L6 or a 6V6, fortunately. Okay, so let's take a look at this and let's estimate what we think would be an appropriate plate current for these KT66s. Let's say they're operating at 450 volts. Okay, we want 70% of 25 watts is what they said was a good comfortable maximum. So that would be 17.5 watts. And if you did go to 30 watts, then times 0.7 would be 21 watts. So let's try to stick around 17.5, maybe 18. Looks to me like around 40 milliamps, because that times the 450 plate volts is going to give us around 18 watts. So we can expect then around 450 and 40 milliamps when we turn this on. Okay, I'm going to come off a standby, and remember we're looking for around 450 on the bottom, and up on the top row we want to see a little less than 40 milliamps. Oh, good Lord. Well, I think we can see why they're red plating. They're close to 100% over. Not right at all. Also, that's brought the plate voltage down. I'm going to turn this off. And since I thought initially it might be the coupling caps, but you're not going to have two coupling caps fail exactly the same. And this was quick, so I think it's the negative DC bias circuit that is faulty. And it is not providing sufficient negative DC bias to suppress the plate current down to like 38, 39 milliamps. Okay, so let's flip this jewel over. Drain all the electrolytics and take a look at that negative DC bias supply. Okay, I have all the tubes pulled out so that they can suffer no harm, and I'm connected to the grid of one of the KT66s. I've got the amp on, and we see that it's receiving negative 43.5 volts DC. And as I recall, the tube handbook said negative 65 was more like it. Okay, so this may be just grossly inadequate to suppress the plate current. Let's check what the grid negative DC bias voltage is on the other KT66. And it's a negative 43.8, so it's almost the same. It sure seems to me like that's the issue here. Now, one thing that I discovered, and this amp is on, so I'm not going to stick my finger in here, is a little trim pot right up here that is in the area that feeding the diode for the negative DC bias supply. I'm going to move the trim pot a little bit and see if it alters our bias voltage. Okay, I've got my trusty wooden stick. Let's move that trim pot and see what happens. Okay, I'm going counterclockwise and it lowers the bias voltage. Now I'm going to turn it clockwise and it gets right up there to where the tube manual tells us it should be. Let me set it right at 65, or as close to it as I can get. Okay, let's plug in the tubes and see now what our plate current is. Here's a close-up of that little trim pot. It's all metal. I've never seen one quite like it, and I have no idea if that's original or if it's been added on at some time, but it's sure an old-fashioned looking component. It makes me think either the amp came this way or it was modified very early on. Okay, but it's now set to around negative 65 volts DC for a bias voltage. Let's plug in the tubes and check our plate current. All right, the tubes are in place and they're warmed up. Let's go off a standby and see if our plate current looks a little more acceptable. Well, now it's real low. Okay, we've got our voltages come way up. These are inversely related. Okay, the higher the plate voltage, lower the plate current. So I'm going to get my stick and let's adjust that little trimmer until we get, let's say, 39 milliamps. Okay, let me use my little wooden stick and move the trimmer up until we're right at about 39 milliamps. Well, that looks pretty good, I think. That's an average of about 39 and pretty good match. And also look at that, the plate voltage is right at 450. It's right where it ought to be. I think we've solved the red plating issue and it looks like these tubes are in pretty good shape. I'm going to leave it on now and make sure that they're stable, which will tell us something about both the tubes and the coupling caps. But I believe that this biasing issue is resolved. Okay, about 15 minutes now has passed. Remember, it was 40 and 38 before. Well, it's still right around 40 and 38. So I believe then the tubes are stable, the coupling caps are in good shape, and I think we're good to go. Now it's time to test that volume control. According to the letter, it was the volume pot for channel 2 that caused all the grief. I've got a 50 cycle tone here, and for those of you who can't stand 50 cycle tones, why don't you take off your headphones or turn down your volume. Let's see how the volume control works. Well, it does have a really bad area there, about what, 1/3 of the way up to a little over 2/3 volume. Really nasty. It sounds to me just like a dirty pot, with no disrespect to my local truck stop bathroom. But let's try now channel 1. Well, not as bad, but it's still got it. So what I'm going to do is pull out both of those pots, disassemble them, and let's see what they look like inside and if we can clean them up. You know, before I go to the trouble of pulling those pots out and disassembling them, another thing that can make noises like that on a pot is if the coupling capacitor that protects each of the potentiometers from the plate voltage of the preceding preamp tube, if these are leaky and if they're letting DC get in here into the volume pot, they're not really supposed to see any voltage to speak of, but if they have the DC voltage coming in here as you move the wiper, you can cause a static sound. Okay, so let's just go ahead and turn this on and see for a second if we have DC reaching the potentiometers, both of the volume controls, through the coupling caps. And what I'm seeing here is no steady negative DC voltage being applied. As you can see, it's jumping around down to 0. If it's there, it will register and it will never go down to 0. So I guess it is that they are dirty and need to be cleaned. So let's get started. Well, after removing 6 wires from the channel 2 pot, which was the noisier of the two, I have it out, and it is a pretty filthy mess. And it also looks like it may have already been opened. Okay, so that doesn't bode well for this type of repair, but let's go ahead and open it up again and take a look. Okay, it's apart, and as you can see, it is a slimy mess. Looks like a whole bunch of probably deoxide or some other type of chemical has been sprayed into it. Those are the little fingers that make the continuity. Well, you know what I'm going to do is clean it up with a non-oily cleaner and see if the carbon track shows any type of damage or scratches or anything like that. Here's that 1 megohm track that goes around the inside of the pot, and it looks really clean to me. I don't see any issues. When I test the resistance between this prong and this prong, it's showing 1 megohm, as it should. So I'm going to put it together with just a very light lubrication and see if it works a little more smoothly. Okay, that cleaned pot has been installed. Remember, this was the really noisy one now. Amp is on, everything's ready to go. No static at all, smooth as glass. I don't doubt that it did make static. You saw what a filthy mess it was inside. You know, I'm guilty of this too. People just, it's easier to just spray some cleaner in there and wiggle a knob and hope everything's okay, but over time, all those contaminants just kind of agglutinate inside the pot, and you end up with the mess that we had with this one. So now I'm going to take this one apart, do the same thing, and put it back in. Well, both of the volume control pots have been cleaned and seem to be working just fine. Now I'm going to focus my attention on this obviously overheated 2-watt 100 ohm resistor. It's 2 watt for a reason. Obviously, they recognize that it would be subjected to heat, and it certainly has. And by coincidence, I happen to have an identical carbon comp resistor to replace it with. So let's do. And just to show you how bad these carbon comp resistors can be damaged by overheating, you see here that the 100 ohm resistor now measures 225.5 ohms. Okay, so it's way out of spec, more than double the resistance it should. Right, the new 100 ohm resistor is in place, and I measured this 8200 ohm resistor that follows it, and it's up at around 1000 ohms, so it's way out of spec also. So let's change this joule. And now that second resistor has been replaced with one of exactly the right value but double the wattage, so that it should be able to hold up better over time. And while I was at it, I decided to replace that blue metal resistor with a matching 2-watt carbon comp NOS resistor. I thought, well, if those had failed, how about the bias resistors? And sure enough, on the preamp tubes, both of the bias resistors were way out. I mean, like 2 or more times out of spec, so I replaced both of them. With all the resistors and caps tested and up to spec, I went ahead and plugged in the amp and started applying stronger and stronger input signals, and something really scary happened. The channel 2, the high treble channel, developed just an intense oscillation at relatively high volume levels. Now, I'm telling you this rather than showing it to you because oscillations are scary. They can cause a lot of harm, and I did not want to destroy this output transformer or these output tubes. What I did was I hooked up the oscilloscope, and I started back here at the first preamp tube grid and looked for signs of oscillation. None, none, none. Okay, we went through the phase inverter, and when I got to the grids of the KT66s, the oscillation would occur and would shut the tubes down. This is probably what was responsible for the dead spot in what the owner thought was the fault of the number or channel 2 volume control. In reality, I think the oscillation was developing and shutting the volume down and the tubes themselves when it got to that volume level. Okay, so the cure, I used something that Fender used in their higher wattage circuits, and that is I put a very low value capacitors to ground from each of the KT66 grids. What this does then is as the oscillation begins, it will take it to ground and stop it. Sure enough, with these small capacitors attached, I watched on the oscilloscope, cranked up the channel 2 volume, and as it got up to the area where the normal type sine wave would start oscillating terribly, it was absolutely stable. So I'm confident then that these 2 capacitors here have solved the problem. I contacted the owner and asked him about the tube set that he had supplied, and he said he would rather have the new TAD tubes installed and biased, and I don't blame him. You might as well get the amp back with a new set of output tubes and have it properly biased. So I did that. So now we are all fixed up, checked out on the oscilloscope, and ready to go with our audio demonstration. I'm going to have Ollie and Jack play some familiar tunes for us and some of their own personal compositions, and we're going to try humbuckers, single coils, and P90s We'll do neck, bridge, and both pickups, and we'll test channel 1 and channel 2 and give this amp a really good testing procedure so that you can see how it sounds with all different pickups and at all different settings on the 2 channels. Well, I guess that does it for this video on the rare and wonderful Marshall JTM-45. I hope you enjoyed it. We're celebrating here in Rusty's workshop that we finally reached the 100,000 subscriber level, and we couldn't have done it without you all. So every one of you who subscribed, thanks so much for helping us finally reach a goal that we set, I don't know, 6 or 7 years ago and really didn't have a whole lot of hope of ever achieving. I'd also like to extend my heartfelt appreciation to all our PayPal contributors and Patreon patrons who have kept us on the air and advertising free for another month. If YouTube is putting ads into my videos, I apologize on their behalf. They're doing it without my permission, and I'm not making a cent from it. I also wanted to thank Mike Mendito for the fabulous gifts, and our old friend and artist extraordinaire, the Jster, who sent us this magnificent oil painting of Jack reclining on the windowsill. Okay, it will soon be available for viewing at the Louvre. Now, this won't be the one in Paris, France, but the one in Paris, Texas. And now it's time to introduce our Part 2 video, in which I'll share with you a pretty scary experience I had recently while repairing a Super Reverb amp. Okay, you'll see why it's kind of scary, and if it's ever happened to you, perhaps my approach and solution to the problem will help you if it ever does. Okay, so if that sounds interesting, please stay tuned. Thanks so much. Well, greetings out there in YouTube land, and welcome to today's big video, which will be a change of pace for us. Instead of simply going through and restoring a blackface Super Reverb like you see before you, we're going to address a very serious problem that this particular amp has, and it's a problem that people have contacted me about and asked me questions about. So first off, let's see what's wrong with it, and then we're going to follow a very logical pattern of addressing different parts of the circuit in an effort to repair that problem. Let's discuss our setup here. I've got the signal generator on and putting in a 600 cycle per second tone. That way we'll know if the amp is alive or not, if it works, and we can also sort of judge its gain by cranking the volume control up and down and listening to how loud that 600 cycle tone gets. Okay, I also have my Eurotubes probes under each of the 6L6GCs, and most importantly, I have the amp plugged into my trusty current limiter. Okay, so let's go ahead and, well, before we turn it on, I wanted to tell you, I already tried to turn it on once, and nothing happened. I checked and the fuse had been blown. Okay, so that's our first hint. Something's drawing a little too much current here. Okay, let's see if we can get it to happen again, or to give us some kind of clues as to why that's happening. Step one, I'm going to turn on the main power. You'll see then that our Eurotubes probes are showing that the circuit is getting the 120 volts on the primary portion of the circuit. Okay, now let's let it warm up for a while, then we'll come back and flip the standby switch and watch in mute amazement at what happens. Okay, we've given plenty of time for the tubes to warm up. Now let's flip the standby switch off of standby. Wow! Oh, well, now that I changed my underwear, let's start to address what we just saw. First off, apparently there's nothing wrong in the primary circuit that's drawing too much current. The moment that I engaged the high voltage circuit, however, you saw what happened, and thank God for the current limiter. Okay, let's check to see if it saved the 2 amp fuse. First, I have to unplug the amp from the current limiter because I have no idea how this fuse holder is wired. And secondly, let's open it up, take a look at our 2 amp fuse. and I don't know if you can see in there, but it's perfectly fine. So our current limiter prevented even 2 amps of current from flowing in here and further damaging the circuit. Okay, so you can see the beauty and necessity of the current limiter. Alrighty, now let's pull the tubes out, flip this over, and take a look at the high voltage circuit and see if we can detect anything wrong. Now before we start poking around in here, I want to be sure that I discharge all of the electrolytics, and I'll use this really snazzy tool that was made for me by a very talented viewer. We'll go through and ground all of the positive ends of the electrolytic capacitors through a 100 ohm resistor. Okay, so now there can be no residual voltage being stored in the circuit. To test that, I'm going to go ahead and hook the voltmeter up and be sure. So we see here at the initial point that the B plus enters the circuit, we have a grand total of 0 volts potential. So the circuit is safe to navigate. Okay, you have to do this every time that the electrolytic capacitors are energized. Let's do a quick sweep here. And it looks to me like the circuit's been heavily worked on. Most of the blue molded caps have been replaced. I don't see any areas where you would see a lot of heat. Oh, wait a minute. Right here, that's the screen resistor. 470 ohm screen resistor for the second 6V6. Now, if there is a short in the screen within the tube, it can cause exactly the symptoms that we've seen. Okay, so, and you know that these metal film resistors do not show this type of heat easily. Okay, so this thing has been just through hell. Probably the fuse saved it from just burning up. So I think we better test the second 6L6 to see if there's any internal shorts. Okay, I've got the tube plugged into the Hickok 600A tube tester, and over here we're going to test different positions here which will see if there's shorts within the tube. Okay, you don't want that light to come on right there, so let's go, we'll go to position 5, nothing, 4, 3, sustained elimination equals short within the tube. We'll go on here 2, 1, so number 3, I don't really know exactly what position of the tube that's testing, but we know it relates to the screen because that screen resistor overheated. Now if you don't have a tube tester with the short testing capability, all I really had to do was just substitute another 606 for this tube and see if the problem went away. If it did, then there was something wrong with this tube. We weren't exactly sure what it is. When you use the tube tester and the short testing feature, you can tell exactly what's wrong with the tube, and it does have a short somewhere in the screen wiring. Also, the tube's quite warm. Now, so what we'll do then is replace this tube with another. Now this tube, it happens to be a JJ, which I've had, if you've been watching my videos for long, quite a bit of problem with. Okay, I will not use JJ tubes anymore. If you love them, great, keep on using them and good luck. But about the 4th or 5th time that one let me down, I've decided I would rather try different brands. Okay, just a word to the wise here. Okay, so this tube is junk. Let's replace it. Before I replace the faulty 6L6, I'm going to replace the burnt screen resistor. It's supposed to be 470 ohms, and as you can see, these metal film resistors really do hold their value. Okay, but that dark burnt spot there was the giveaway that there was something wrong with the screen of the tube. So let's install a similar but brand new and unburnt 470 ohm resistor. Okay, here you see that the new screen resistor has been installed, and I usually put them off to the side. Remember, the amplifier chassis is hanging so that the heat will rise upward and just roast the socket and the resistors. So it's best to keep your resistors out here a little bit out of the line of fire. Okay, so now let's flip this jewel over, put in that replacement 606, and see if the problem is solved. Now it's time for our final test. The old JJ tube with the shorted screen has been replaced with a vintage 606 GC that I know to be a good tube. Signal generator is putting in the same 600 cycle tone. I've been in a power on position now for long enough for the tubes to warm up. Let's go ahead and take it off of standby. And the amp is working. Wow, look at the difference in current flowing through the vintage tube compared to the JJ tube. Okay, you can tell that's not a very well matched pair. But the point is, even with that amount of current flowing, the current limiter is not lit, the amp is amplifying, all is well in the world. I think it's time to get rid of this JJ and order a nice matched pair of tubes for this amplifier. So just a quick review of what we learned here. Number one, use a current limiter whenever you're plugging in any amp of unknown functionability, okay? They come in the mail. I don't know what's right or wrong with them, so I always plug them in. And as you can see, it saves a lot of grief. Number two, look at all the components, especially resistors. For signs of overheating. They can give you a clue where that extra current is going if you've got a dead short situation like we had with this. Okay, also drain your electrolytic capacitors every time you touch a circuit, and only touch it with one hand when you do. Okay, so that's about it. We'll put little excerpts like this in from time to time in videos whenever I think a good kind of like a teaching point comes up that I want to share with you all, and I hope you appreciate it. Thanks for watching.